This is the first of 3 lectures on bipolar disease. Many students have asked to learn more about bipolar disease in order to be able to help friends or relatives who seem to have a disorder somewhere on the bipolar spectrum. Unfortunately, it's rather frustrating to discuss bipolar disease because we know so little about its pathophysiology, about its genetics, or about the way that drugs act which gives some but not complete relief for bipolar disorder. As usual, we'll begin with a clinical description. We'll talk about the genetics of bipolar disease, about possible causes, about a heterozygote advantage in which people with just a few of the genes predisposing to bipolar disorder might have an advantage, and about drug or other therapeutic approaches. First, we begin with a clinical description based on DSM-4. Bipolar disorder affects between 1 and 1.5% of the population in most modern societies. It was formerly called manic depressive disorder because patients have one or more manic or nearly manic, hypomanic episodes, alternating with major depressive episodes. The first episode is often in the mid-20s, which is a bit later than major depressive disorder and a bit later than schizophrenia, but this is quite variable. And bipolar disorder, unfortunately, often leads to suicide. I base a lot of my description on a major scholarly work by Fred Goodwin and K. Redfield Jamison called Manic Depressive Illness. It's now in its 2nd edition. And as you'll see, K. Redfield Jamison has been very active in this field with other books as well. There's also a very nice summary of bipolar disease on the NIMH website. You can download the PDF or PowerPoint of the lectures, and this link will be in it. And it's also on the link about background material on the course webpage. DSM-4 defines a manic episode as a distinct period containing an abnormally and persistently elevated expansive or irritable mood. This period of abnormal mood must last at least a week or less if hospital is required. Returning to Winnie the Pooh, Tigger is not having manic episodes. That's simply his constant bouncy personality. So there needs to be a difference between one's regular mood and a manic episode. The mood disturbance must be accompanied by at least 3 additional symptoms: inflated self-esteem or grandiosity, decreased need for sleep, pressure of speech, flight of ideas, distractibility, increased involvement in goal-directed activities, or psychomotor agitation. So a typical manic episode might be a person who maxes out his credit cards, for instance. Excessive involvement in pleasurable activities with likelihood of painful consequences. Typical manic episode might involve sexual escapades. The mood may be irritable rather than elevated or expansive. And once again, as in all psychiatric diseases, the disturbance must be severe enough to cause impairment in social or occupational functioning, or to require hospitalization, or has frank psychotic features. So that is a manic episode. And we go back to our chart of mood disorders in DSM-4. We have 3 actual disorders on the bipolar spectrum. And so bipolar 1 is the classic cycling between manic episodes and depression. Bipolar 2, the manic episodes are not so high. In fact, they could be called hypomanic, nor are they so frequent. However, the depressive episodes are just as severe, and rapid cycling may be present in either bipolar 1 or bipolar 2 disorder. Cyclothymia, meaning literally cycles of up and down moods, involves less severe mood swings in each direction, manic and depressive, but these are persistent and recurring. So we have this spectrum of bipolar disorder, and DSM-5 is very likely going to change this. We'll get to that later. Now, genetics of bipolar disorder is remarkable both for its strong heritability and for the fact that it has not yet been possible to replicate findings of individual genes. This is the classical study of genetics of bipolar disorder in twins, so that one can eliminate the effects of environment. And monozygotic twins show for bipolar 1 disorder a concordance rate of 80%. That is, if one of the two children has bipolar disease, the chances are 80% that the other will. Very similar for bipolar 2. Dizygotic fraternal twins drop markedly, especially in the concordance for bipolar 1. They drop to 13%. Now, there are various ways of describing heritability based on these data. In general, heritability means the amount of the variation from one person to the next that may be caused by genetics. Bipolar 1 is clearly very heritable. Bipolar 2, less so. And in contrast, major depression, which does show a strong genetic component, has less heritability than bipolar 1. Studies on twins adopted into different families are rarer, of course, but they show little effect of the adopted parents. Instead, the major effect is the biological parents. The fact that there's such a large difference between monozygotic and dizygotic twins is a good indication that no single gene causes bipolar disorder, rather that one requires several, and by several we don't know whether it's 2, 3, 8, or 10 genes to be mutated at the same time. And again, in genomic studies, no individual genes stand out in replicated studies. Well, what about the possible causes of bipolar disease? As for schizophrenia, as we'll see in a later lecture, each new advance in neuroscience has been tried out on bipolar disorder, and there is no satisfactory explanation yet. But as for schizophrenia, the general present theories invoke circuit properties and early developmental events rather than individual transmitter systems and individual cell types. In the absence of any generally accepted animal models for bipolar disease, we can't say much more about the pathophysiology of bipolar disease. Next time we'll talk about the heterozygote advantage in bipolar disease.